Okay. So what is a relation? A relation is something that is between any two quantities. For example, a relation between...
What happened? Hello?
Yes, yes. Okay. So we have a relation between two of us, that is a student-teacher relation. So relation is always between any two quantities. The relation
Hello?
is visualized with an input-output machine. And in mathematics,
Yes.
what is the input-output machine? The input-output machine is in the form of a table or in the form of a graph. So here I have put one example of a table. It is time and the height. So what is the time here? We're inputting time and we're getting output as the height. So what does this input-output machine called?
Hello?
Hello, yes, yes, can you hear me?
Yes, I can hear you. My headphone is acting weird. Sorry. I'll just
Okay. So
I'll switch to normal ones.
okay, so this is an input-output machine that is showing time and the height. Time is the input and height is the output. Let's take another example of a graph. For example, if I have graph, I have kilometers run per week by Nida in the horizontal axis. And I have the weight loosed by Nida on the vertical axis. Okay. So we have what input you are giving. The input you are giving is that you are running.
Fine.
So this is the input. You are running, this is the input. So what is the output you are getting? The output you are getting is that you are losing the weight. So that is the output. So the graph can be something like this. So this is an input-output machine. So what is a relation? Relation is always between any two quantities. So it represents, in mathematics, a table or a graph represents a relation between the two quantities. Coming to the function, as we know what is relation, we can define function. What is function? A function assigns exactly one output to each input. So if a relation, in a relation, if every output is assigned by every input, if there is only one output for every input, then that relation is called function. If there is only one output, the condition is one output for each input. What is the meaning of output? Y value. One Y value for each input means X value. So I'm defining in the mathematical term, for each X value, we have only one Y value, then that is called a function. And if we have multiple Y values for the one X value, then it means it's not a function, it's a relation. Okay. So I was asking you the question that I have a graph over here, this, I have a graph over here, this, I have a graph over here, this. Do you know which of the graph is a function? And we know all of the graphs here are relation. There is any one quantity here, any one quantity here. So there are two quantities, so it is a relation between the two quantities. Similarly, this graph is a relation between the two quantities. This graph is also a relation between the two quantities. But we don't know if this graph is a function or not. So do you know how to determine if the graph is a function or not? The question is,
how to determine
if graph is a function or not.
I know this answer. Exit.
Okay, so give me some guess.
Okay.
Can you guess?
No, I can't. All numbers. I knew, but I forgot. I'm sorry. I think we do a line test.
Yes, excellent.
Yes,
There is a test that is called, the name of the test is vertical
line test. Yes.
line test,
Yes.
and the test is VLT.
VLT.
So what this vertical line test says, it says if you can draw a vertical line that crosses or touches the graph, I'm writing it so that you can
Voice.
know it and you can remember it. If you can draw a vertical line that crosses or touches a graph at more than 1 point, I'm writing with this red that it's important, then
Touches.
graph does not represent the function. Okay,
Yes.
we will do several examples to understand this. For example, here I have a machine. We have to input something and we will get the output. So what is the
Yes.
function in the machine? The function in the machine is y is equal to 2x minus 1. So is this function a graph or not? The function is y is equal to 2x minus 1. Is this function a graph or not? To determine if this function a graph or not, what we need to do is make a table. Okay. And put some random values of x to get the values of y. We can put 0, 1, 2, -1, -2. If we will put 0 in the x, what we will get? -1.
Sorry, I'm writing. Yeah.
Okay.
X
If we will
to
put 1, 2 times 1 is 2 minus 1, 1. Let's put 2, 4 minus 1, 3.
Yes, make a table.
Let's put -1, -3. Let's put -2, -5. So when we get a lot of values of x and y,
we can graph it.
okay, for x is 0, y is -1. Just random graph, okay? X is 1, y is 1. X is 2, y is 1, 2, 3. X is -1, y is -1, -2, -3. And x is -2, y is somewhere -5. The graph is going like this. It's a straight line going like this. Okay. So now with another color, I'm using green over here. I'm going to test VLT, vertical line test. I'm going to put a vertical line. Is it crossing 1 point? Yes, I will put vertical line crossing 1 point. Anywhere on the graph, if I will put a vertical line, it will cross only 1 point. So if a vertical line test is passes, it means
Only
vertical
once.
line test passes. Why? Because it's only cuts 1 point. So it means vertical line test passes and the graph is a function.
Vertical line test.
Understand?
Yes.
Let's do more examples. I have an input-output machine in this form.
And a function.
2, -8, 1, 4, 0, 5, 3.
This is -8, the second one?
Yes.
Okay. 8.
Okay. You are going to tell me if this is a function or not.
Uh, so number of y can be two or three, but x can only have x can have 2 or 3 y's, but y cannot have 2 or 3 x's. Is that damn it. Okay, let's see if I can solve this.
So we know that for every input, we need only one output. But for the
Okay.
input 1, we have more than one outputs, 5 inputs.
Yes.
So it is not a function.
Oh, not. Okay. Yeah, I was not
Why
sure.
it's not a function? Because for every input, we need only one output. But here in the case of 1, for input is 1, but the outputs are 2. So it's not a function.
Every output. Oh, for every input.
For every input, there should be only one output.
It is not a function. Okay.
Is this graph a function?
If you do the line test, no, it's not, because in the middle is it has 2 values.
When we will draw a line, it will cut the graph at 2 points.
Yes.
So it's
Yes.
not a function.
Okay. I'm just gonna draw this real quick.
Why it's not a function? Because vertical line test fails.
Okay. VLT fails. Not a function. Okay, got it. Another example.
Okay. Tell me, is this a function or not?
-3. For every input there's an output. Yes, it is a function.
Yes, because for every input, we should have only one output. For 0, we have -3. We have one output for 0 and one output for 8. Maybe the outputs are same. But for one input, there is one output. So, yes, it is. I'm giving you just 2 minutes to just look on all of these examples we have done.
Yes.
I have tried to cover the examples of each category.
Okay. Yeah, you can move forward. Hello?
Yes.
Yeah, okay.
Just wait a minute. Can you see the screen?
Yes.
Okay. So let's do a reading from the book. Okay. So algebraic functions. A function is a special kind of relation in a function for each input. For each input, there is exactly one output.
Okay.
Here it is written. In a relation, there can be more than one output for a given input. So it might be a relation, but every relation is not a function because function has condition. What is the condition for the function? For each input, there should be
It has to
exactly
be
one
one.
output.
Yes.
This is the condition for the
Yes.
function. Okay. So now, looking at a relation, consider the relation that shows the heights of all students in the class. The domain is a set of the people in the class and the range is a set of the heights. So what is the domain? Set of all the people? DJ, Maya, these are all the people in the class, and some people have 62, 72, 70 different heights. This relation is a function because each person has exactly one height. If any person had more than one height, the relation would not be a function. So if one person has more than one height, the relation wouldn't be a function. But if every person would have only one height, the relation would be a function. Okay.
Yes.
Coming to next, notice that even though the same person can't have more than one height, it's okay for more than one person to have the same height. Okay. So the reverse is
Yes.
possible that we have done in the example number 4. In a function, more than one input can have the same output. More than one people have a height of 62 inches. Okay. So more than one input is okay, but more than one output is not okay. As long as more than one output never comes from the same input.
Okay.
Determining if a relation is a function. Determine if the relation is a function. The easiest way to figure out if a relation is a function or not to look all the x values in the list or the table. If a value of x appears more than once and it pairs up with different y values in relation is not a function. So more than one x values for different y values. Okay, you can see it's 1, 3, -1, -2, 3, 5, 2, 5, 3, 4. So you can see that in this relation, there are two different y values paired with the x value of 3. This means that it is not a function. Okay, let's check this. There are two different y values paired with one value of, okay, that's the easiest way. What we can do is it's 1, 3 means 1, 3. -1, -2. 3, 5, 2, 5, 3, 4. So y value is 4 and the x for one input value, we have two output values. What were we saying? That if we have one input, it is the input is 3, but the outputs are 2, 4 and 5. So in this case, it is not a function. If you are facing difficulty determining the function in the form of the ordered pairs, you can write it in the form of the list, all the x values here or the y values here. And then what you will do, you will see if one input is giving more than one output, it means it's not a function.
It's not a function. Okay, got it.
Okay. Now, trying the next one, option 2, that is -3, 20, -5, 25, -1, 5, 7, 12, 9, 2. So
everything
for
has
all
one.
x
Yeah, that's a
values have
function.
only one output. Every x
Yes.
value can give only one output. So relation is
Yes.
a function over
Function.
here. Okay, now we know how to tell if a relation is a function or not, but we are going to learn how to tell if a graph is a function or not. So for learning about the graph, determine if
The
a
first
graph
one
is
is
a
not.
function. When a
Yeah, the
relation is
first one is
represented
not.
graphically, yes, what are you saying?
I'm saying the first one is not because it's coinciding at
Vertical
two
line test.
points.
By
Yes, vertical line
how
test.
we can tell that graph is a function or not? By using vertical line test. What is vertical line test? We will draw a vertical line along the graph. If the vertical line touches more than one point in the graph is not a function. So this for the graph, a circle is a graph and the red line is the vertical line if we put on the circle. So it is crossing on the 2 points because the vertical line test says it should only pass to the 1 point. So vertical line test fails. And graph is not a function.
Okay.
In the
I'll
second
tell
case,
this one. This one is a function.
A function, let's draw the vertical line. It is only crossing one graph at the one point here, here. So vertical line test passes and it is a function.
Yes.
More example. For the following graph, determine if they are function or not.
Yeah, it's a function.
First one, vertical, let's draw the vertical line here, passes the 1
Mhm.
point, 1 point. So yes, vertical line test passes and that is a function. For the second one, it is crossing the
It's
2
not.
points. So
Yeah,
no,
2 points.
it's not a function. Okay. In 1 to 8, determine whether each of the relations is a function or not. So tell me, I'm giving you just 2 minutes. So you can tell me about the part 1.
Part
We have
1.
some ordered pairs.
Okay. Yeah. 2, 7, 3, 8, 4, 8, 5, 9, and 3. So the first one is a function.
First one is a
Second
function
is-
1, 2, 3, 4, 5. Yes.
And then 1, minus 1, 4, 2, 4, minus 2, and 3, minus 3. So second one is not a function because
Because
it
for
repeats like
1,
x.
we are getting 2 y values. One
Yes.
input and 2 y values.
Yes,
So
it's not a
yes for
function.
it, no for it. Okay.
No for it. And then minus 4, minus 4, minus 3, minus 2, minus 0, and then 16, 9, 4, 1, 0. So the third one is a function.
Yes. For every one input, we're getting one output.
Yes.
Fourth.
Yeah, 2, 0, 6, 0, and 3 and 6. Yeah, for no, it's not a function because 2 has 2 values, minus 6 and 6.
2 has minus 6 and 2 has 6. Very good.
Yeah, and
5.
Fifth one is a function because it has just one value for every input.
Good. 6 1.
Yes, it is a function, 6 one also.
Good.
Because for every it has the value.
7th one.
7th one is yes, it's a function. Every value has its own
8th
output.
one.
8th one is age. Huh? How are you gonna do this? Age 2025. Number
I
of
think
dogs.
it's 20, 25, 25, 30, 35. It's like this 20, 25,
Oh, is it?
25,
Okay.
30,
Okay, hold on,
35. And the
hold on.
number of jobs are
25,
3, 4,
30,
7, 4, 2.
35.
I think it's like this.
Okay, 3, 4, 7, 4, 2. So one value.
So 2x values.
No, there are 2 x's.
2x
So
values for 1
it's
y
not.
values, and so
Yeah.
not a function.
So not a function. So even if you have 2 x's, they are present, that also is not a function, right?
Yes, this is the
Okay,
easiest
yeah.
way to check.
Yeah.
And now there are graphs, so you need to do the vertical line test.
Okay, I'll do this.
9 and 10.
So the first one is 9th is a function, and 10th is not a function.
Because when we
test,
draw a line, it only passes 1
yes.
point, so vertical line test
Mhm.
passes. But here we draw a line, it
fail.
passes 2 points, so vertical line test fails.
Mhm.
Understand?
Yes, got it.
Do you get something about what are relation, what is a
Yes,
relation,
yes,
what is a
yes.
function, and
Yes,
everything?
alhamdulillah. Yes.
Okay. Let's move on.
Yes, please.
Coming to domain and range. Okay. Here you will learn to identify the independent variables that are called domain and the dependent variables that are called range of the function. You and your 3 friends are debating which theater to choose for a trip. The movie is on Friday. There are 4 theaters in the town, all with the 3 different prices of tickets. The most expensive theater charges $12, but has stadium sitting and a screen 5 stories tall. The cheapest is only $5 per ticket, but only plays older movies and is much less comfortable. The other two are between $8 and $9. If you were to graph total cost of 4 of you based on which theater you chose, which values would you represent in the domain and which in the range? Tell me.
So domain will be, domain is the input, right? So it is the
Domain
X
is the
value.
input.
So it will be the 3 friends.
The 3? No, the theaters. There are how many theaters? 4 theaters.
The
The
4
domain would
theaters.
be 4 theaters, 4 different theaters,
Yes.
and
Yes.
range would be the prices and the qualities.
Yes.
Okay. So
Yes.
what is the domain? Domain is the X values on the x-axis. In other words, it is called independent. So just write it down. What is the domain? Domain has 3 names. Domain is also called X values. Domain is also called independent variable.
And it is called the input value, right?
Yes,
X
it is
value?
also called input value.
It is called independent value. Okay.
Range is Y values. It is dependent values. And it is the output value. Okay, so independent variable domain. The domain of a function is defined with a set of all x values for which the function is defined. For example, the domain of the function y is equal to 3x is a set of all real numbers, often written as R. This means x can only take in a real number. Other functions have restricted domains. For example, the domain of the function y is equal to square root x is a set of all the real numbers greater than or equal to 0. The domain of the function is restricted in this way because the square root of a negative number is not a real number. Therefore, the domain is restricted to non-negative numbers in this case. Okay, so you might have done this in the previous classes, but let us revise this. What are real numbers? So what are real numbers? The first question arises here is,
real numbers are not whole number, they're not fractions, they're just I mean,
oh,
they
what happened to you? Real numbers are whole numbers.
Are whole numbers. Sorry. They are whole
They
real
are
numbers. They're not
fractions.
fractions. They are
They
fractions.
are decimals.